My channel is Electrons, and in this video we'll be talking about this past question from electronic system design. So for this particular one, um, a criminal pretending to be a customer successfully hid himself. A criminal pretending to be a customer successfully hid himself within the operational area of a commercial bank with the intent of robbing the bank. Please, guys, no matter how we read this thing, no matter how we read this thing, put your mind on what you are asked to do. Don't worry about the story, whether it's a criminal, whether it's not a criminal, whether it's. Don't worry, just put your mind on what you're asked to do, okay? So let's continue. So, with the intent of robbing the bank at night after the operational hours, in an attempt to what solution? The management needs to know the number of customers that visit their bank daily. You are not constrained on choice of component. That means you can use as many components as you want, whichever components, but it should solve the problem. So a brief explanation on the components and procedure will be an advantage. So you can explain the components and explain, yeah, the procedure. So one door is designed as in and the other out. You are also required to use different display for inward and outward movement tracking. Now, to solve the problem of detecting criminal hiding inside the commercial bank after closing hours, a bidirectional people counting and movement tracking system will be designed. This is the solution, okay? All right, so when we say bidirectional counting system, we mean the system can count in both ways, okay? People inside and then people outside. So bidirectional counting system, okay? So let's say this is in and then this is out. So that's bidirectional counting system, a system that can count both ways, bi-directional, two direction, okay? So to solve the problem of detecting criminal hiding inside a commercial bank after closing hours, a bidirectional people counting system, people not object, people counting and movement tracking system will be designed. Now the system will monitor the number of people entering, that is the indoor, and the number of people exiting outdoor. The total number of persons inside the bank and trigger an alarm if someone remains inside after closing time. Meaning, when someone goes into of course, at the beginning stage, everything is just zero, nobody inside. When someone goes in, there will be a count 1. Another person goes in, here will be 2. Another person, here will be 3. If someone leaves, it will be what? Minus, so it will come back to 2. Are we getting it? So it's something like once we have in, somebody goes in, you see 1. Another person goes in, here becomes 2. Somebody goes in again, here becomes 3. Somebody goes out, here becomes 2. Somebody comes in, here becomes 3 again. In again, here becomes 4. Out, here becomes 3. Okay, this means that there are still 3 people left inside. At the end of the day, we should see what? There should be 0. This is not 30, this is 0, okay? At the end of the day, we should have what? 0. If this is not 0, it means there's still somebody inside the bank. Then after operational hours, of course, there will be time set. At that time, and after that time of operation, and this number is not 0, the count is not 0, then the alarm will be what? Triggered. So that's the idea. Okay. So yeah. Now the design will use what? The design will use sensors, of course. Sensors as the input unit, a microcontroller as a processing unit, counting logic as a firmware, which is a software. That is writing of program. So programs will be written. That written program is what we refer to as the firmware here. Then display as output units and alarm circuitry. So we have an alarm system, and then we now have the display units. Okay. So for each door, the in and out door, 2 infrared sensors will be installed in order to detect direction of movement using sequence logic. Now this is how it is. Okay, I've written something like this before. So this is how it is. We'll have two sensors. Let me take these guys out so that we'll see what's going on here. Just give me like a few seconds. Okay, so we'll have two sensors. Okay, let's say sensor one, and sensor two. So this one will be the out sensor, and this one will be the what in sensor. So these two sensors, if this one is triggered before this sensor is triggered, it means the person is going inside the bank. Because if you are walking inside the bank, you are just strolling inside, you will trigger this sensor before you trigger the sensor. That means the person is going in. So the count will be what? 1. But if this sensor, the out sensor, is triggered first before the sensor is triggered, it means the person is walking like this. Okay, the person came from this side, walking like this before this one is triggered. It means it was out sensor. That means the person is going out. So -1. Okay, so that's the idea. So for each door, 2 infrared sensor will be installed in order to detect the direction of movements using sequence logic. When a person walks through, if in sensor, like what I said, is triggered before out, it is regarded as what? Inward movement. If out sensor is triggered before in sensor, it is regarded as what? Outward movement. So a microcontroller, maybe Arduino or PIC or any embedded controller, will be used as the brain, which is the processing unit of the system. Then of course, to display the number of people, the count, a liquid crystal display will be connected to show the number of people inside. This allows security personnel to monitor the number of people in the bank. After bank hours, if n is still greater than 0, that means the number of people is not equal to 0, is greater than 0, man, that means there's still somebody inside the bank. So activate the buzzer with the alarm. So this ensures that any hidden person is what? Detected. Below is a block diagram of the system. So of course, 2 infrared sensor, okay, the in and the out. Both of them will give inputs to the microcontroller. Of course, power supply to the microcontroller. And the microcontroller will now send what? Will give signal output. So the LCD, that's a liquid crystal display, to display the number, and also to the buzzer to give sound in case there's somebody left inside the bank. Then the advantage of this system is that it's real-time monitoring, meaning as the people are entering into the bank, you are seeing the count increasing, the number is increasing. Then automatic operation, you don't need to count by yourself. A human, like the security or any human or any man or anybody, and there is no need for anybody to go there and count how many persons don't enter. You one, they will now climb somewhere and write on top of the LCD 1. Anybody inside again? Now write on the LCD 2. No. So it happens automatically. Okay. Then low human error. Of course, since it's automatic, the human error is what? Reduced. Okay. Almost negligible. Okay, but let's just say low human error. Then expandable for CCTV integration. Because all we did here, we did not mention CCTV, but the point is that it's what? Expandable. So that's all for this video. We'll stop here and I'll see you in the next one. So thanks for watching, and like, share, subscribe, and I'll see you in the next video. Bye for now.